Okay, good evening folks, welcome back yet to another video. Must thank my viewers and subscribers. So this video is on matrices. Alright, so a basic definition of what a matrix is that it's an array of rows and columns enclosed in a bracket. Alright, and inside these brackets we have elements. Alright, it could be numbers, could be letters, it could be names, etc, etc. Alright, and we can describe a matrix by its dimensions. Alright, so for example, in this matrix, a typical matrix here, say A. Alright, so if we go across here, we realize that we call these rows. Alright, so this is row 1, row 2. Coming down here we have column 1, column 2. So this matrix has 2 rows and 2 columns. We call that 2 by 2 matrix. Alright, so this is a 2 by 2 matrix. The first number tells us the number of rows, and the second number tells you the number of columns. Alright, okay, so I mean we could go into types of matrix: square matrix, null matrix, unit matrix, and all those kind of things, but I'm just gonna skip through that. And what we're gonna look at how to add and subtract matrix, and we will be mainly looking at 2 by 2 matrix. So in this example here we have 3 matrices, A, B, and C. Alright, so the question says to find A plus B. Alright, so A plus B, what we do is set it out like that. Alright, and how we add matrix, what we do, we add this entry with this other entry. Alright, so the 3 and the 0 corresponds. Alright, so it's a 3 plus 0, and the 3 plus 0 will give you this element here. Alright, and then we look at the negative 2 and look at this 2. So these 2 elements here would add together. So this will be negative 2 plus 2. Negative 2 plus 2. Likewise, the negative 1 goes with the 5, and 5 goes with the negative 1. So that's how we add matrix, and the same way we add matrix, same way we subtract matrix. Alright, so as clearly as you can see, 3 plus 0 is actually 3, and negative 2 plus 2 is 0. Negative 1 plus 5 is actually 4. And at this point here, remember I told you that whenever you have 2 signs together, we use the rules of multiplication. So a positive and a negative will give us a negative. 1 from 5 will give us 4. Alright, now what I want you guys to try is to flip around this matrix. So rather than saying A plus B, I want you guys to work out B plus A. Alright? Alright, so you're gonna pause the video and try that. Okay, so after you have tried that, B plus A turns out to be, what do you notice? The same thing as A plus B. Alright, so A plus B when adding matrix is equal to B plus A when adding matrix. In other words, the addition of matrix obeys what we call the commutative law. Alright, just like how we have, like, for example, let's say we have say 5 plus 8. Alright, 5 plus 8 plus 8 is 13. If I flip it around, 8 plus 5 is also 13. So addition of integers obey the commutative law. Alright, so look at this: 3 fours, 12, 4 3s, it is still 12. So of matrix obey the commutative. Alright, so that's that. Let's look at question 2. Question 2 says B subtract C. Alright, and we're using these matrix here, B and C. Alright, so we're gonna set out B. So this would have been B and this would have been C. Now, earlier I said that same way add matrix, same way we subtract matrix. So this 0 and 3 will go together. This 2 and 4 will go together. This 5 and this 1 will go together. This -1 and this -1 will go together. Alright? Okay. So what we have here is 0 subtract 3. Alright, and 2 subtract 4. 5 subtract 1. And check this out. -1. -1 subtract -1. Alright, and let me just get at this right away. You know, when signs are together, we use the rules of multiplication. 2 negative will give us a positive, and -1 plus 1 will give us 0. 4 take away 2 is -2. 3 take away 0 is -3. 1 from 5 is 4. Alright, so what I want you to do, you see, is to work out, flip around these numbers. So rather than B subtract C, you're gonna have C subtract B. Alright, now you're gonna pause the video and try it. Okay, so now that you've paused the video, what do you notice? The answer is actually 3, 2, -4, 0. Now if you look at B subtract C and C subtract B, both of them are different. Alright, let's go look. This is -3, but this is 3. -2, but 2. 4, but -4. And both of these are 0. Alright, so I mean the numbers look the same, but the signs are different, but they're actually different. Alright, so we can conclude that B subtract C is not equal to C subtract B. In other words, subtraction of matrix does not obey the commutative law. Alright, now what I want you to do on your own is this. I want you guys to work out A plus B. Well, we already have, right? A plus B, we already did in the first part. A plus B, I'm still using the same initial matrix, A, B, and C. So this question says to add A plus B, and A plus B we already worked out already, which is this. And the answer we get for A plus B, you're going to add it with C. Alright? Then you write down the answer. And next now, what I want you to do is to add matrix B plus C. Alright, so you can pause the video. B plus C. So you're going to add B plus C. Put matrix A in front of the sum of B and C and work it out. Now you're going to get two answers, right? Now those two answers are going to be the same thing. Alright? So this is also another law. Alright? And it's called the associative law. Alright? So for example, if you have 1 plus 2 plus 3. So if you add the first two numbers, right, you're going to get 3 plus 3, which is 6. What if you add the last two numbers first? You still get the same answer. So we said the addition of integers obeys what we call the associative law. All right. And also, what if you have this? What if you work out the first two numbers? 1 times 2, 2. 2 3s, 6. But what if you work out the last two numbers? What you notice? You still get the same thing. So we can say that the multiplication of integers obey what we call the associative law. Alright, so you've learned about two laws today. The commutative law and the associative law. Alright? Alright, so let's continue. Alright, so what we have here is what we call scalar multiplication. Scalar multiplication is when we multiply a number times a matrix. So for example, in part 5 here, it says 3c subtract 2a. Alright, so we're going to go back to our original matrix value. Alright, so as you can see, they're talking about C and A. So 3C, by the way, this is C, 3, 4, 1, negative 1. 3C is 3 will be the scalar, 3 times every element inside the matrix. So it's 3 times 3, 3 times 4, 3 times 1, 3 times negative 1. Likewise, 2a. It's 2 times everything inside the matrix. So it's 2 times 3, 2 times negative 1, 2 times negative 2, 2 times 5. Alright? And when you work out these two products here, 3 3s, you're going to end up with this. Alright? And then now, after you finish out multiply the scalar, then we're going to subtract these two matrices. Alright? So this is going to be, remember when we're subtracting matrix, right? We subtract entry by entry. So these two matrix, these two elements that correspond, right? So it's going to be 9 subtract 6, 12 subtract negative 4, 3 subtract negative 2, negative 3 subtract 10. All right. Okay, just to point out something here, you see, whenever you're doing subtraction, right, don't try to do this. Don't try to say negative and negative give you positive, and negative and this negative give you up. Don't do that, right? What you should do is just to do what I'm doing right here. All right, that's the safer route. All right. Okay, so then now 6 from 9 is 3. When signs are together, we use the rules of multiplication. 2 negative will give us a positive. 3 plus 2 is 5. Same thing for this one. That's going to give you 16. Well, this is different, not true? Alright, the signs are not together. So in this case, we're going to say, okay, you know something, you owe and you owe. You owe 3 and you owe 10. You owe 13. So that's our answer. Alright, so we're going to move on. Alright, so we're going to look at matrix multiplication. Now, matrix multiplication is slightly different from addition and subtraction of matrix. Alright, now whenever we are multiplying two matrices, we multiply row by column. Alright, and in this example here, we're going to multiply two by two matrices. Alright, so what I'm doing, I'm going to start off with some letters. Alright, so what I'm going to do, I'm going to show you how to get this first element. That's the first element in the first row of the first column. All right, remember what I said. How do we multiply a matrix? Row by column. All right, so to get this element there, we're going to use this first row of the first matrix with the first column of the second matrix. So we're going to say A multiply by E plus B multiply by G. All right, and this combination will give us this element. Let me show you how to work out this element. All right, so this element is found in the first row of the second column. So we're going to still use the same row, the first row. So it's going to be A multiplied by F plus B multiplied by what? H. All right, so I'm going to show you to get this one now. So I'm not going to use the first row, I'm going to use the second row of the first matrix. So it's going to be this row with this column. All right, so that's how we multiply matrix, row by column. So, and when I say column, I mean columns going, you're going to start, you're going down. So it's going to be C multiplied by E plus D multiplied by G. All right. Can you tell me how am I getting the last one? What combination? You can pause the video and try on your own. All right. So now that you have paused the video, let's continue. So to get the last one, we're going to use the second row of the first matrix with the second column of the second matrix. So it's going to be C